HVAC Temp-Rise formula for measuring airflow. CFM is essential because it ties the heater's actual heat output to the measured temperature rise, to give a true airflow number that prevents undersized or inefficient systems. For accurate CFM using the temperature rise method, first measure the supply and return dry bulb temperatures at 5 to 7 points across the registers, average them, and record the steady state rise after the system runs for at least 5 minutes. Next, measure supply voltage and motor current at the blower while the system is under normal load to capture real power input, not nameplate values. Convert measured volts and amps into input watts using measured volts times measured amps times the motor power factor if you can measure it. If not, use a conservatively tested power factor value from the motor nameplate testing or motor manufacturer data to avoid underestimating heater wattage. Add any supplemental electric heat elements, wattages, from direct measurement or from their stamped rating, and subtract known control losses only if you have validated measurements. Otherwise, include them to avoid underreporting heat. Use the specific heat of air at the operating dry bulb and wet bulb conditions or standard value of approximately 0.254 British thermal units per pound degree Fahrenheit times air density to convert the Desnand measured temperature rise into mass flow and then to volumetric flow, and apply the formula CFM equals heater watts divided by 1,260 times temperature rise in degrees Fahrenheit when heater watts are in watts, and you convert units appropriately. Always note that panel voltage fluctuations and motor slip change blower speed, so correlate volts and amps with tachometer or static pressure checks to confirm blower performance. When measuring amps, use a true root mean square clamp meter on the motor lead and avoid inrush readings by measuring after the motor reaches steady state. If using single-phase motors, measure both legs and average only if the supply is balanced. Document every reading with timestamps and ambient conditions, and repeat the test under at least 2 operating modes to verify consistency and rule out transient errors. One of the most common mistakes is using nameplate voltage and amperage instead of measured values, which yields inaccurate heater wattage and then wrong airflow CFM. Fix this by measuring actual volts with a reliable meter and measuring current with a true root mean square clamp meter while the system is running steady. One of the top issues is ignoring power factor on motor-driven heaters and assuming unity, which underestimates real power. Fix this by obtaining the motor power factor from manufacturer data or measuring it with a power quality meter, then include it in watt calculations. One of the frequent errors is poor temperature sampling, too few points, or taking readings before steady state, causing biased temperature rise. Fix this by taking multiple evenly spaced register readings after a stable runtime and using consistent instrument placement and probe insertion depths. BigHomeProjects.com lists trusted HVAC contractors and service pros so homeowners can quickly find technicians who perform accurate temp-rise airflow testing and electrical measurements. The directory also helps contractors get work by showcasing verified trades, customer reviews, and contact details so qualified HVAC pros connect with local jobs.